Okay, so I'm Amelia Snyder. I'm a master's student at Oregon State University, and I'm working with Tom Dietrich and John Selker. And my research is a part of the Trans-African Hydro-Meteorological Observatory, more shortly known as TAHMO. So right now, Africa has very few weather stations, and the weather stations that are there are often not reporting a large proportion of the time. TAHMO's mission is to change Africa from a very sparsely stationed region of the world to one of the most densely weather stationed regions of the world by deploying 20,000 weather stations in Sub-Saharan Africa. And we're working with the Meter Group, who designs these really small, durable weather stations that are very cheap. We can put them all over Africa, and they have no moving parts and require very little maintenance. We give them to the local Met agencies so that they can use them for predicting agricultural productivity or severe weather events. We also provide the data free to any academic and research purposes so that they can be used for monitoring or forecasting climate change. And they can also be sold by the Met agencies for any commercial purposes that might be interested in these data. And we install these weather stations in schools so that the schools receiving them can use them as an educational resource as well in their classrooms to have a more hands-on understanding of some of the science concepts that they're learning about. So my research specifically is looking at optimizing the network design of these weather station networks. And I have four main interests in this research. The first is that we want to accurately reconstruct the field of weather in space and time. We want to be getting good data from these weather stations. But we're also interested in thinking about how we can combine these different variables that have different units in ways that are actually meaningful. What weights do we need to place on different variables to get the data that's most important to us? After we think about that, we want to incorporate social and political considerations. So we don't just want the best data overall, but we want the best data where it's most important. For example, agricultural areas may need this weather data more than, a remote region where no one is living. And lastly, we want to look at different ways to think about objective functions and which objective functions are how they're going to affect the network design and which one is the best to use for our purposes. So in March, I took a trip to Benin, Togo, and Ghana, and I met with the local Met agencies, and I talked to them about their goals for these weather station networks, and I also went out in the field and visited some of the sites where they want to install these weather stations and did some installations myself so that we got a better understanding of the real-world constraints that we're dealing with in terms of deploying these weather station networks, as well as maybe some unique opportunities that we hadn't considered before. So if you'd like to hear more about my research, please come visit me at my poster. Thank you.